In this video, we're going to look at another example of centroids and moments. The question here is to find the centroid of the plane region bounded by the curves y equals sine x, y equals cos x equals pi over 4, x equals 5 pi over 4, with density rho is equal to 2. So we start by sketching the bounded region. Basically, we have the sine x graph, that's the top function, and the cosine x, that's the bottom function. Pretty easy to draw. Let's label these. So f of x, the top function, is equal to sine x. We call it a top function because the top part of the rectangular slice meets sine x. And the bottom part of the rectangular slice meets cosine x. G of x is equal to cosine x. X is between 5 pi over 4 and pi over 4. So basically, let's shade the region. This is the shaded region here, and our goal is to find the mass of this region, the moment with respect to the y-axis, the moment with respect to the x-axis, and of course we want to find the centroid, x bar and y bar. So let's apply the centroid formulas to do that. Mass is equal to rho, density, integral a to b, f of x minus g of x, and integrate with respect to x. The density is equal to 2. Integrate from pi over 4 to 5 pi over 4. Top function minus bottom function. Sine x minus cos x dx. So the mass is equal to 2 times. What is the antiderivative of sine x? That's going to be minus cos x. And what is the antiderivative of cosine x? That's going to be sine x. Evaluated from pi over 4 to 5 pi over 4. Let's factor out minus 1. It will make the computations a bit easier. So we get minus 2 times cosine x plus sine x evaluated from pi over 4 to 5 pi over 4. So mass is equal to minus 2 times. And now apply the fundamental theorem of calculus. Putting the upper limit in, we get cosine of 5 pi over 4 plus sine of 5 pi over 4 minus, put the lower limit in, we get cosine pi over 4 plus sine of pi over 4. All right, what is the cosine of 5 pi over 4 and what is the sine of 5 pi over 4? So 5 pi over 4 is in the third quadrant, so here's pi plus pi over 4. The reference angle is pi over 4, and we know from the special triangles, the 1, 1, root 2 triangle, where these angles are pi over 4 and 45 degrees pi over 4. So basically, cosine of 5 pi over 4 is going to be negative 1 over root 2, because in this quadrant, cosine and sine are both negative. So mass is equal to minus 2 times cosine of 5 pi over 4, this is negative 1 over root 2, plus sine of 5 pi over 4, this is also minus 1 over root 2, minus cosine of pi over 4, this is 1 over root 2, plus sine of pi over 4, this is 1 over root 2. So the mass is equal to minus 2 times minus 1 over root 2, minus 1 over root 2, minus 1 over root 2, minus 1 over root 2. So there's 4 of these. We get minus 4 over root 2. And multiply all of these out, and we get 8 over root 2. Let me just redraw this special triangle. It wasn't done very, very good. So let me just redraw that. So this is basically 1, root 2. And this angle is 45 degrees. This is pi over 4. And this angle is also pi over 4, 45, 45, 90 degrees. And so sine of pi over 4 is just opposite over hypotenuse, is 1 over root 2. Cosine of pi over 4 is also 1 over root 2. But because we're here in this third quadrant, cosine and sine are both negative. So cosine of 5 pi over 4 is negative 1 over root 2. And sine of 5 pi over 4 is also negative 1 over root 2. All right, we found the mass. Now let's find the moment with respect to the y-axis and also the moment with respect to the x-axis. Okay, so the moment with respect to the y-axis, this is equal to density times the integral from a to b times the distance to the y-axis, which is x, times f of x minus g of x dx. So moment with respect to the y-axis, the density is 2. Integrate from pi over 4 to 5 pi over 4, x times f of x, which is sine x, that's the top function, and the bottom function is cosine x, integrate with respect to x. We're going to apply integration by parts. So recall the formula. The formula is integral u dv is equal to uv minus integral v du. That's the integration by parts formula. So we're going to let u be the polynomial, let u be equal to x. Differentiate both sides, we get du is equal to dx. So this part is u, this part here, the polynomial. And all of this, sine x minus cos x dx, this part is dv to be integrated. So dv is equal to sine x minus cos x dx. And when we integrate dv, we obtain v. What is the integral of sine x? This is negative cos x. What is the integral of cosine x? This is sine x. So the moment with respect to the y-axis is equal to 2 times u times v, that's x, times negative cos x minus sine x, evaluated from pi over 4 to 5 pi over 4, minus integral from pi over 4 to 5 pi over 4, v times du. V is minus cos x minus sine x times du, which is dx. So the moment with respect to the y-axis is equal to 2 times. So we get minus x. Let's now simplify this. Minus x cosine x, multiplying x through, and x times minus sine x, we get minus x sine x. And let's do the integral of the second integral. We get minus minus is plus. Integral of cos x is sine x. And minus times minus is plus as well. And integral of sine x is negative cos x. Much more efficient to write it all on one line and just tack on the limits at the very end. This way it's less likely to make mistakes. Pi over 4 to 5 pi over 4 are the limits. And now we apply fundamental theorem of calculus. Put the upper limit in and then put the lower limit in. Moment with respect to the y-axis is equal to 2 times. Putting the upper limit in, we get minus 5 pi over 4 cosine of 5 pi over 4 minus 5 pi over 4 sine of 5 pi over 4 plus sine of pi over 4, plus sine of 5 pi over 4 minus cosine of 5 pi over 4. Subtract, now put the lower limit in, minus 2 times negative pi over 4 cosine of pi over 4 minus pi over 4 sine of pi over 4 plus sine of pi over 4 minus cosine of pi over 4. And close off the bracket. All right, let's evaluate that. So the moment with respect to the y-axis is equal to 2 times negative 5 pi over 4 times cosine of pi over 4, cosine of 5 pi over 4, we get negative 1 over root 2 minus 5 pi over 4 times sine of 5 pi over 4, that's also negative 1 over root 2, plus sine of 5 pi over 4, that's negative 1 over root 2, minus cosine of 5 pi over 4, that's going to be minus minus plus 1 over root 2. So we get a cancellation. Cancel, cancel. And then minus 2 times negative pi over 4 times 1 over root 2 minus pi over 4 times also 1 over root 2, 1 over root 2, plus sine of pi over 4, which is 1 over root 2, and cos of pi over 4 is 1 over root 2 as well. So we get another cancellation. All right, so this part here is the cosine of pi over 4, and this part here is the sine of pi over 4. This part here is sine of pi over 4, and this one is cosine of pi over 4. So there's a lot to simplify. If we simplify this, we get moment with respect to the y-axis is equal to 2 times 5 pi over 4 root 2 plus 5 pi over 4 root 2 minus 2 times minus pi divided by 4 root 2 minus pi divided by 4 root 2. All right, so looking at this very carefully, we get moment with respect to the y-axis is equal to 2 times 5, that's going to be 10 pi over 4 root 2. So 10 pi over 4 root 2 plus, and 2 times another 5 pi over 4 root 2, that's going to be 10 pi over 4 root 2. Distributing the minus 2 times minus pi, that's going to be plus 2 pi over 4 root 2. And it's a common mistake not to distribute this negative sign on the second term. So minus 2 times minus pi, that's plus 2 pi over 4 root 2. We have the same denominator, so we can just add up the numerators. So the denominator is 4 root 2. We have 10 plus 10, that's 20 plus 2 plus 2. We get 24 pi in the numerator. So the moment with respect to the y-axis, and 4 cancels with 24 gives us 6. We get 6 pi divided by root 2. That's the moment with respect to the y-axis. So now let's define also the moment with respect to the x-axis. This is rho times integral from a to b, 1/2 times f of x all squared minus g of x all squared dx. So the moment with respect to the x-axis is equal to 2 times, the limits are pi over 4 to 5 pi over 4, 1/2 times f of x squared. Well, f of x is sine x, so we get sine squared x minus g of x squared, that's going to be cosine squared x dx. The 2 cancels with a 1/2, so we get moment with respect to the x-axis is equal to integral from pi over 4 to 5 pi over 4 sine squared x minus cos squared x dx. Now, how can we simplify this to make the integration easier? Well, we can apply a trig identity. We know that cos squared x minus sine squared x, this is equal to cosine 2x. So let's apply that. But we have sine squared x minus cosine squared x, so the integrand is simply going to be minus cosine 2x. So let's just change that to minus cosine 2x, applying a trig identity, and now it's easier to integrate. So the moment with respect to the x-axis is equal to minus, what is the integral of cosine 2x? That's going to be sine 2x divided by 2. Evaluated from pi over 4 to 5 pi over 4. So the moment with respect to the x-axis is equal to minus 1/2. Put the upper limit in, we get sine of 2 times 5 pi over 4, that's 10 pi over 4. So sine of 10 pi over 4 minus, put a lower limit in, 2 times pi over 4 is pi over 2, we get sine of pi over 2. Now, what is sine of pi over 2? That's sine of 90 degrees, this is 1. 10 over 4 is the same as 2.5, so 2.5 pi, basically we have pi here, 2 pi, and 2.5 pi is going to be the same as pi over 2. So sine of 2.5 pi is equal to sine of pi over 2, so we also get 1 here. Sine of 10 pi over 4 is 1. So the moment with respect to the x-axis is equal to negative 1/2 times sine of 10 pi over 4, which is the same as sine of 5 pi over 2, which is the same as sine of 2.5 pi, which is the same as sine of pi over 2, because sine x is a periodic function with period 2 pi. So we get 1 minus 1 is 0. The moment with respect to the x-axis is 0. So we have mass. Mass is equal to 8 over root 2. We found that earlier. And the moment with respect to the y-axis is 6 pi over root 2. And the moment with respect to the x-axis is equal to 0. So what is x bar going to be? Well, x bar is equal to moment with respect to the y-axis, divide by the mass, and that gives us 6 pi, divide by root 2, divide by the mass, which is 8, divide by root 2. So we get 6 pi, divide by root 2. Flip the denominator, we get root 2, divide by 8. Root 2 cancels, and we simplify. 6 pi over 8 is the same as 3 pi over 4. Let me just write that a bit better. This is 8 here. All right, so that's x bar. What about y bar? Well, y bar is equal to moment with respect to the x-axis divided by the mass. But the moment with respect to the x-axis we found to be 0. Divide by 8 over root 2 is equal to 0. So we found x bar, the x-coordinate of the center of mass of this region is 3 pi over 4. Y bar, is the y-coordinate of center of mass is 0. This is a centroid. Let's show this on a diagram. So going back to the diagram, where is it? I think it's on page 1. All right, so the x-coordinate of the center of mass is 3 pi over 4. The y-coordinate is 0. So notice that we found x bar to be 3 pi over 4 and y bar to be equal to 0. All right, thanks.